In this section, I want to focus on the revision of the lesson that we're doing on LCM, as well as the highest common factor that involves factorization. So what I did is I grabbed a few previous papers so that you can see how these are brought about in an exam. So this paper is the paper that was written on the 24th of July 2018, just a day before my birthday. My birthday month is 25th. So this was 24, and the 25th is to me a special day. Anyway, this question paper was written on the 24th. As I said, it's your mathematics in 2, and let us look at the question that covers the section that I'm interested in. Now it's question number 2. That is where you're going to find these questions on LCM, as well as the highest common factor, which is an HCF. So let us look at this question number 2, and if I can have more space to work on, like that. So let us look at our question number 2. This is where we'll focus on. 2.1 says this is what we're given: a squared plus 7a minus 8, and 4m squared minus 9y squared, 2m squared minus 3ym. Now question 2.1 says fully factorize each of the following given expressions. So you get 3 marks for that. I think they were a little bit stingy there, because some of the similar questions can go up to 7 marks. But anyway, let us look at each one of these and see how you can solve them. So we have got a squared plus 7a minus 18, and the way to solve this, I use the product sum, where this is 1. I multiply that to give me my product of negative 18a squared, and my sum, which is positive. The product is multiplication, my sum is positive, which is the center there, which is positive 7a. So sum means plus. So now I'm looking for the factors there. I'm looking for 2 numbers, whereby when I multiply them, I get negative 18, and when I add those 2 numbers, they give me a positive 7. So in other words, I'm looking for the factors of 18, which is 1 times 18, which is 2 times 9, which is 3 times 6, and then 4 is not a factor, 5 is not a factor, 6 is a factor, but it is 6 times 3. So this is basically all these factors. Now remember, I need to get a negative, so it's either 1 is negative and 1 is positive. So for example, minus 1 times 18, or 1 times negative 18, minus 2 times 9, or 2 times negative 9, negative 3 times 6, or 3 times negative 6. Now the decider is the sum. When I add one of these numbers, I must get a 7, positive 7. Remember, it's only one set of numbers. So if I say minus 1 plus 18, this one is totally out. It's minus 1 plus 18, not 18. I'm getting a 17. Minus 2 plus 9. I'm getting a positive 7, which is what I want. But let me try the others just for your sake. Minus 3 plus 6 is off. 1 minus 18 is off. 2 minus 9, it's a negative 7, but I want a positive 7. And 3 minus 6, it's a negative 3. So the answer that I'm looking for from this is the one which is that. So my factors are negative 2x and positive 9x. So when I'm solving from here, I will get a squared minus 2a. Actually, it's not x. I was supposed to write it in terms of a, because we're not dealing with x there. So minus 2a plus 9a minus 18 there. And looking at the first 2, a is common. It is a minus 2, and then 9a minus 18, 9 is common, which is a. 9 into 18 is negative 2 there. So when I've got these matching, means I'm factorizing correctly, which is a minus 2 and a plus 9. So that is the first part that I have then to say when I factorize. Remember, all this working is very important for you, but because of my space, I will have to be working on the same part, so I'll keep on erasing. So when I factorize this, I'm getting equal to a minus 2 and a plus 9. So that is what I got. If I move on to the next one, I'm supposed to factorize 4m squared minus 9y squared. So I'm looking now at the second one. Now when you factorize that, it's two items. The first one had 3, that's why we use the product sum. Now there are 2, and most of the time I always remind students to say whenever you look at these, it can give you an idea whether you must use the product sum, whether it's a difference of 2 squares, whether you are grouping, so that you can be able to to guess your way through, just to be sure of what you're doing. So when I've got 2 items in this expression, chances are it is a difference of 2 squares. Now you can actually see it. 4 is 2 squared, m squared, and 9 is 3 squared, y squared. So you need to first express everything with a square. So don't be tempted to say from here you say 4m minus 9y, because 4 must be expressed first as a difference, as a square. So you need to express everything as a square. Don't think that if m is a square and y is a square, you can now start applying the law to say 4m minus 9y and you have got your 4m plus 9y. This will become wrong because you didn't express the 4 in terms of the square. So don't forget that. Now when you have done that, you need then to, with the square, you have your 2 brackets. And I say to students in a way, pretend you don't see these squares. And if you don't see these squares, what do you write? You write what you're seeing, which is 2m minus 3y. So that is basically what you'll be doing whenever you are factorizing that. So it will be, if you just ignore the squares, it's 2m minus 3y and 2m. Now you change from negative to positive 3y. That's what you're having. That is the answer to that. So this is equal to 2m minus 3y and 2m plus 3y. And when you've done that, that is the factorized part. Again, this was 1 mark. So the last one is 2 items again, which is 2m squared minus 3ym. Again, you have to check that chances are it is a difference of 2 squares, so try to express everything as a square. Now I cannot express 2 as a square, so automatically it means it's not a square. Even I cannot express y and m as a square, so which means I can just do a normal factorization whereby I look at the common items and m is common, so I'm dividing by m. So it's more of, I'm saying 2m squared over m to cancel out to remain with 2m minus, and then I'm doing the same thing again. I'm saying 3ym divided by m so that I get minus 3y. So basically that's what I'm doing when I'm factorizing for the common term. So it's 2m minus 3y. So when I do that, it will be 2m minus 3y. And now I'll also encourage you to have an idea towards when you're working with such problems. You can see that 2m minus 3y, it also appears in the second one. There is a 2m minus 3y. So when such things appear like that, it gives you an assurance that you're working in the right direction. So now for that, they'll give you a mark, and a mark, then you get your 3 marks. The next question now says, give the lowest common multiple LCM of the three expressions. Now, when we are finding the lowest common multiple LCM, what you need to do, you need to ensure that all of the brackets are represented. So, for example, the first bracket is a minus 2. So, I need to make sure that you write everything so that it's represented. I have a minus 2. Next is a plus 1, plus 9. Next is 2m minus 3y. Next is 2m plus 3y. Next is m, but I can write it in front here so that because it's just 1, it's m. Then next is 2m minus 3y. But now there is something not right with the last one. As you can see, I've got a 2m minus 3y here, so I don't have to repeat it, hence this is already represented. So the answer then will become that part. This becomes my LCM. And the last one says find the highest common factor. Now the highest common factor is the one that is common to all the three. That's why they gave it a mark. The other one was 3 marks, this one is just 1 mark. So it must be common in all the three. So the first one, you look what is appearing. In the first one is a minus 2. In the second one there is no a minus 2. In the third one there is no a minus 2. There is an a plus 9. Now in the second one there is no a plus 9. In the third one there is no a plus 9. So in this case there is nothing common. So the highest common factor there, we can say it is 1. So 1 is the only one that can go into the first, into the second, and into the third. Don't force it to start to say 1 cannot be the answer there, but in this case it's only 1 and no other one can become the highest common factor of the expression. Now let us look at the next one. It's also a paper. Now this one was written just a few months back in November 2020. As you can see, this is the last exam that was written. Let's see how they brought the question across. So now in this question they are saying, looking for question 2. Now they did it in question 2 in question 2.2. Now let us look at question 2.2. Again, it's talking about given the following algebraic expressions. So they've given you now something interesting. They have factorized that. They have factorized that, and they have factorized that. So everything is factorized. Now the question is, determine the highest common factor of all the expressions. It's just 1 mark. So you're just looking and writing. As I said, the highest common factor is the one that must repeat in all the three. So we start with 3. You can see that 3 is not appearing in all the three. And then the A as a single standalone letter, it is also not appearing. Even the B is not appearing. Now let's try AB minus 4 and AB minus 4 and AB minus 4. So you can see that in all this, what is repeating highest common factor is equal to AB minus 4. So that is what is repeating in this. So that 2.2.1, that's what you get. It was your AB minus 4. The next one is determine the lowest common multiple of all the three expressions. It's 3 marks now. The lowest common multiple is everything. You're just writing everything that is represented. For example, you have got for LCM, we have 3, we have A, and we have B, and we also have 2. So I can actually, I'll put it in a bracket like that. We have 2, and then we've got A, B minus 4. You're just writing everything. We have A, B plus 4. Now I cannot write AB minus 4 more than once because it is repeating, and then I must have 3x plus y. So remember, it's the lowest common multiple, but you must not repeat anything that is the same. So we have 3, we have a 2, the a, the ab minus 4, ab plus 4, and 3x minus y. Sometimes it is also fine, instead of having a 3 and a 2, some might say you multiply 3 times 2 to get 6ab, because in 6 there is 3, and then in 6 it's a factor of 2. So you can still do that. 6ab, ab minus 4, which is that, and then ab plus 4, which is that, and 3x plus y, which is that. I'm ticking this so that all of them are represented. So that is how you solve this kind of question. Now 2.3 was another interesting one. Says fully factorize the following expression. Is 3 marks. So you are given that part, and it's 3 items, and when it's 3 items, remember, chances are you have to start with the product sum. So we're given 6x squared y minus 17xy plus 12y. So I keep on repeating this letter y. 6, 17 and 24, there is nothing common, but there is something common in the letters, which is, in this case, I have the y, and the y. So I can take out that y first. When I take out that y, remember, it's like I'm dividing. It's actually what I'm doing. I'm dividing 6x squared y divided by y. I will have inside the bracket 6x squared, the y will cancel, minus 17x, the y will cancel, plus 12. So they will give you a mark for that. This is one of the 3 marks there, to identify that I needed to take out y first. So when you have done that, you can then use your product to say 6 times 12. I think it is 72 there. That's the my product is that and that. That's my product, which is if I can say, it's not n equal as such. So my product is equal to positive 72x squared. My sum, which is for plus, is equal to minus 17x. And then I'm looking now for factors, and in these factors I'm looking for the factors of 72, which is 1 times 72. So pick a number, but you need to go through them. 2 times 36. You need to be also able to use your calculator to assist you. So you say 72 divided by 2, that's why we say 36, and 72 divided by 3 is 24, which is 3 times 24. Then you do the same, 72 divided by 4, which is 18, which is 4 times 18. Again, you try 72 divided by 5, it won't do, because 5 is not. And then 72 divided by 6, which is 12. Now it will be, I continue there, 6 times 12, and then I continue 72 divided by 7. It's not giving the answer. 72 divided by 8, I get a 9, which is 8 times 9, and then 72 divided by 9 is 9 times 8. So when you repeat the numbers, it means you have reached an end. So it's 72 divided by 8, and then it will be 8 times 9, and then 72 divided by 9 is 9 times 8. When you start repeating these numbers, it means you have reached the last number. When you have done that, you come back to say, of these numbers, of these factors, when I add them, the decider of the factor is this one, when you add these factors. Now when I add these factors, I must get a negative. So for me to get a negative, for me to get a positive, the product there is positive. It's either both numbers are positive or both numbers are negative. For example, to give you an idea what I'm talking about, It's either, if I'm looking at 2 and 36, it's either I'm saying 2 times 36, I will get a 72, or I'm saying minus 36 times negative 2, I will still get a positive 72. So both numbers must be negative and both numbers must be positive. So let's start with the first one. When it's the first one, if I say 1 plus 72 is far from the sum of 17, 2 plus 36 is also far, and then 3 plus 24, remember both numbers must be positive or negative, is also far, and then 4 plus 18 is also not the number, 6 plus 12 is also not the number, and then 8 plus 9 is giving me 17. So which means if I say minus 9 minus 8 minus 9 is minus 17. So these are the factors, which is minus 8x minus 9x. So when I solve it, just to have space, so it will be equal to, in this case, 6x squared minus 8x minus 9x plus 12. Now remember, you have the y which is remaining on the outside. If you forget that y, your answer will be wrong. So which is equal to y. Now you put, because you're going to be dealing now with more than 2 brackets, so you put a y, first bracket. Now what is common in the first two? 6x squared minus 8x. Between 6 and 8, what is common is 2. Then x squared and x, you take the smaller power, which is x, then you open the bracket. So you are dividing 2 into 6 is 3, x into x to the power of 2 is x, minus 2 into 8 is 4, x into x is 1. So the next thing is you put a positive. In as much as the signs you see they are different, minus and plus, always take out a positive. Now 9x plus 12, 3 is common, and you are saying 3 into negative 9x is negative 3x. 3 into 12 is positive 4. So now it is when you identify, then you close the bigger bracket like that. It is when you identify that 3x minus 4 minus 3x plus 4, they are similar, but the signs are the only ones that are different. So you'll have 3x in this case minus 4. Now from positive 3, you take out a negative, it becomes negative 3. Then you interchange the signs. From negative 3, it becomes positive. From positive 4, it will become negative. So you can see that the brackets are now, what is inside the bracket is now the same. So you will have your y. If you write for your brackets, it will be 3x minus 4, and you have your 2x outside the bracket minus 3. Then close the bracket like that. So this is what they expected you to write as the answer there. So if they said factorize that, of course you can't just write an answer, but this is the answer here to say y 3x minus 4 and 2x minus 3. And then lastly, let us look at this other question here. And this other question says we need to factorize x to the power of 16 minus 81. So now when they wanted to solve such in here, when they wanted to solve such, which is x to the power of 16 minus 81, you must ask yourself 2 items that I'm dealing with. Chances are it's a difference of 2 squares. So what is this 81? So it will be x to the power 16. Now I want to show you something that you could have approached. You are like 81. I know 81 is 9 squared. You know it's a square, so you can say that. That is one way, but I'll show you the other version that you could have used. So 81 is a square. You must know the square numbers. 81 is a square. Even 9 is a square. Already you can have an idea there. So 81 minus 9 squared. Then you are going to have two brackets, which will be, now how do you deal with this? So you'll have your x here and your 9. You have your x and your 9. Remember, negative and positive. The issue now is the powers. So whenever you're given that, what you're simply doing is saying 16 divided by 2 and 2 divided by 2. That is basically what you're doing there. So if you're saying 16 divided by 2, you'll get your 8. 9 divided by 2, you get your 1. Again, you repeat there and there. Now, if you know your difference of two squares, you will realize that x to the power 8 minus 9 is not complete. So always focus on the one that is negative. The positive one is done, but the negative one is not complete. Hence they say 3 marks. So what you do, you remind yourself that this is same as x to the power 8 minus 3 squared, and then x to the power of 8 plus 9. Then you do the same thing to say, if I open the brackets, then we'll have here x to the power of 8 plus 9. Now x to the power 8 minus 3, you do the same thing, you're dividing by 2. So 8 divided by 2 is x to the power of 4, and then you have 3. X to the power of 4, you have 3. It's a negative and a positive. Now you cannot express 3 as a square, therefore this will mark the end of your answer. Just for, as I said, I will show you two ways you could have approached it. There was another way you could have approached also, but still it was going to lead to the same answer. Now what I was saying is, if you had, in this case, your x to the power of 16 minus 81, so now it is your calculator in this case that must be handy to know that 81 is also 3 is a factor of 81. But if I say 3 to the power of 4, you can see 3 to the power of 4 is 81. So this is 3 to the power of 4. Now when it's like that, it's already a difference of two squares. As I said, you write your x, your 3, your x and your 3. One is negative and one is positive. Now the powers you are dividing by 2, so 16 divided by 2, you have 8. 3 divided by 4 divided by 2, you have 2, and then you repeat 8 and 2. Now you continue to recognize that I still have a negative and my powers are still able to be divided by 2, both of them. As long as your powers are even numbers, it means continue. So there must be a negative sign and even numbers. So you will have x and 3 here, and you'll have x and 3, and then lastly you'll have your x to the power of 8 plus 3 squared. Now when you continue there, remember you are dividing 8 divided by 2, you have 4. 3 divided by 2, you have 1, and then you repeat now with a positive like that. Now you check again where there is a negative sign, because that's where the difference of two squares is in the negative sign. Now you have 3 to the power 1, which cannot be expressed as a difference of two squares. So your answer will be x to the power 4 minus 3, x to the power 4 plus 3, and x to the power of 8. Now 3 squared is plus 9. You can leave it as 3 squared, but I just wanted to show you that it matches exactly that. There is a way that you can prove your answer, and one way of proving your answer, I would say proof, is what I usually tell students to say. What you can do, you can choose any number. You say, for example, let my x be equal to 7, just any number. Then with that number, you are going to substitute where there is x. Let me do that. Where there is x, for example, on this one it's x to the power of 16 in the original, so it will be 7 to the power of 16 minus 81. You get your answer. Again, you go to your original where you are writing x to the power of 4. You will have your 7, and your 7. The answer that you get here must match the answer that you get there. So let us try it. For example, if I say 7 to the power of 16 minus 81, I think it will be a big number, which is 1,17119 times 10 to the power, I think this is too big. Let's choose 3 because 7 seems to be big. Let's choose 3. 3 to the power of 16 instead of 7. I would say my x is 3 minus 81. It's this big number, 430. I think let me go back to 7. I don't know why I made an error there because it was a funny number. Let me try again. 7 to the power of 16. Oh, I forgot to play forward. Minus 81. Okay, this is much better. It's 3,32 times 10 to the power of 13. 3,32 times 10 to the power of 13. I must get the same answer in my final answer that I got. Is my bracket. Remember it's 7, which is 7 to the power of 4. Play forward. Minus 3. Close the bracket. Open another one. 7 to the power of 4. Play forward. Plus 3. Close the bracket. Open another one. And then 7 to the power of 8 plus 9. If I do that, I must get a similar answer, which is 3,32 times 10 to the power of 13, which is exactly what I got in this one. So whenever it's matching like that, the chances are you are in the right direction. So this is what I use usually when I want to check quickly if my answer is it correct or it's wrong. Alternatively, though it's much longer, you can prove it if you have got enough time in your hands at the exam. You can expand and expand and expand and expand. The answer you get, you expand with this one and you expand with that one. It's a bit longer, but it must take you back to your x to the power of 16 minus 81. I hope this was making some more sense as we revise this factorization, the highest common factor and the LCM, so that when you look at other previous question papers, you can be able to solve them. Thank you.